So we got a lot of stuff to cover today. We're going to talk about Agent 3. We're going to talk about the architecture behind Agent 3. We're going to talk about how things work at Replit, give you a look into the culture, and hopefully give you a look into how tools like Replit are built and deployed at scale to millions of users. We think that this is going to be a casual conversation. It'll be fun. But first, I'm going to spend maybe 10 or 15 minutes talking about what Replit is, what Agent 3 is, to frame the conversation. So we're going to discuss some of the features that we've built, some of the exciting things we think about Agent 3, and then we're going to use that as part of this discussion. Um, I love Royal Otis, but if somebody at the iPad could cut the music, please, that would be awesome. Uh, I'm sure they'll take care of that. And again, I love Royal Otis, so I have some background music. So to kick it off, I'm Matt. I lead developer relations. And today we're going to be hearing from three engineers at Replit. James Austin on the AI team. We're going to welcome them up in a second. Darsh Patel working on product, and Jackie Zhao working on infrastructure. We're going to talk about Agent. We're going to talk about what's new. So what is new in Agent 3? What's different? Well, first, there's a longer runtime, and we like to pride ourselves. We think this is the longest running production agent on the market. 3-hour plus runs, some users up to 6 hours of just AI writing code and testing itself. And that's what we're going to talk about next, self-testing. We're going to explain how we did that. I'm going to show you a demo of what that is. And third, agent generation. So if you're following along at Dev Day yesterday, OpenAI announced Agent Kit. We're doing something a little different. We're just writing code, and some of the Master folks were outside before the event, but we're using Mastra, which is a TypeScript open source framework for building agents, to write agents purely in code. So at the end of the day, it's just React, or rather, it's just TypeScript that you can take with you, you can manipulate. And we're going to talk about connectors as well, which is going to enable some really cool stuff. So longer runtimes, 200 minutes plus, self-testing, agents going to debug our applications, and agents and automations. And these things all kind of tie together. That's what we're going to talk about today. So self-testing, what does that even mean? So in front of me, I have a Chrome browser. This is Playwright. And there's like a little cursor. And it's actually using, on a whiteboard Canvas app, it's testing the application. So if you've all built apps, if you all have written code, vibe coded, you probably know that part of it is figuring out what's broken because it never works on the first try. So our thinking is, well, why doesn't AI just do that for you? And so Agent 3 can test itself. It can test the apps that it's creating. What that enables, there's longer feedback loops. Because Agent can say, oh, hey, does the chat box work? Like I'm going to send a test message there, and then I'm going to see that it came through. Well, it can actually just keep coding. And if something's broken, it can fix that. Our engineers are going to talk about the challenges and interesting kind of like nuances behind that. But I'm going to show you a few other apps, a few other cool things. So this is the whiteboard app I just showed off. What are some cool things that Agent 3 enables here? Well, if you've ever built something like this, you might know like a real-time multiplayer whiteboard app can be pretty tricky, right? Because what's going on here? Well, under the hood, if you want to sync the state, you need like a database. You need some way of tracking like multiplayer cursors. And if I type in like, hey here, oh gosh, touchpad with the microphone, we have a real-time whiteboard app. So this is two separate browser consoles we're looking at. And this was one prompt. This was one prompt to agent with a little over a 2-hour run. So because of the self-testing, because of more autonomy and things that we've built in, what we get is an agent that runs by itself for 2 hours. So you can go like take a nap or make a coffee or just like enjoy yourself and come back to something that's a more complete app. So this is a full stack application with a database, self-tested, built by agent in one prompt. So that's kind of what I'm talking about when I say like a longer runtime. What are some other cool things that you can build? So we'll wait for this app to start up for a second. This is like a full media toolkit that I've been playing around with. And the idea here is to show off that Agent 3 has some more like autonomy stuff. So you can allow it to run for longer. You can toggle low, medium, high autonomy. And what you get is like, essentially just a really powerful tool. So sorry, this isn't actually self-testing. What this is our launch video. So the idea here is, who's that guy? The idea here is I built a real-time transcription app. This uses Assembly AI on the back end. You can integrate your favorite tools. You can integrate your favorite services. Replit's going to understand how to help you do that and build something that's really cool. So now you can obviously build things that are a bit more powerful, transcribe things in real time. From that, I make YouTube videos. Sometimes it's really boring to write the YouTube descriptions. You can tie together multiple tools. So more advanced apps. That's another thing that's big in Agent 3. And then finally, agents and automations. So what is this? This is an agent. And so as I talked about under the hood, We're using Mastra. Time-based trigger. Hey, maybe I want to go on Hacker News. I want to understand the latest articles, extract the data, generate a digest with that, and send it to me every day at 8 a.m., every day at 8 p.m. With Replit, it's really easy to do that. And something that I might have glossed over, this is all running in the browser. So you go to replit.com. Difference between Replit and Cursor, right? Replit are these other tools. You don't have to install anything. It's not running locally. It's running in the cloud. You don't have to configure languages. You type in a prompt, you get something back. And what that means is you can iterate faster, you can build faster. Really great for prototypes, really great for all these things. These are all new features in Agent 3, agents and automations, etc. They kind of take things to the next level. And so, what we have here is, nope. Keyboard shortcuts. What we have here is, a Hacker News digest agent. So it goes on the web, fetches articles from Hacker News, summarizes them, and then sends them via email. We also have this thing called Replit Mail, which allows you to send emails without configuring resend or another API like that. So this is just an overview of Agent 3. This is some of what's new. And I'm going to stop yapping, and we're going to bring up the real engineers that built this stuff, and we're going to ask them some questions. It's going to be fun. But to get you guys excited, I got some swag. So if anybody here knows how many languages you can run on Replit, independent of AI, you can actually use Agent on any language on any app that runs a Replit. You want to raise your hand and give me a guess. How many languages can you run on Replit?
25.
No. Up. A little bit lower. Okay, it's 50-ish, give or take. I got a thermos for you here. Replit thermos. Awesome. Okay, is everyone excited now? Okay, this is what I'm going for. Everyone's excited. So Replit Agent, before it was called Agent, it was called something else. It was our first AI product. Does anybody know what it was called? No, assistant's wrong. Think a couple years back, and it's October. That's my hint. It's like spooky. No, you work at Replit. Shut up. No. Close. Ghost was a part of it. Ghostwriter. Replit sweater. Outstanding. And then we got a Replit tote bag. So last piece of fun facts. It says, don't code, just vibe. You will be the coolest person in the room if you have this. Replit is a YC company. What year, and if you get the batch right, that's like extra credit. What year and what batch was Replit in YC? No. 2018. Coolest guy in the room. Look at that, amazing. All right, let's bring our engineers up here and we're gonna have a fun conversation. Thank you all very much. Tabs here, but just leave the screen off. Cool, outstanding. So, we just launched Replit Agent 3. This is very exciting stuff. What is new about Replit Agent 3 that didn't exist in other iterations of Replit? What were some challenges in building that?
So Replit Agent 3, the entire idea was that you should be able to kind of give it, whenever we're working the agent, we want it to be able to be given bigger and bigger tasks, and that it can solve for over longer periods of time, so that you can do other stuff instead of having to deal with the agent directly. So the two big innovations that we have in Replit Agent 3 is that now we have testing sub-agents where we can actually go through and analyze what is actually going wrong with an application, click through all of the stuff that Matt demoed earlier. And then also we're doing a lot more introspection about what kind of code that the agent is generating to make sure that we can solve a lot of those really common issues. Mocked data, just general code quality, test coverage, all of those things.
Very cool. So you said testing sub-agents. That implies that there are more agents than one. So is this what we call a multi-agent architecture?
Yeah.
And was the older version of Replit Agent multi-agent?
When we first launched it, we actually tried having a multi-agent architecture. The idea was that you would be talking with one agent that would kind of figure out exactly what you wanted, and then would kind of give that task to we called it the editor sub-agent. The issue was that it added a lot of cost, and also it meant you would ask really basic questions, and it would turn into a game of Chinese whispers, where your main agent would be like, I need to know what's going on. Okay, yeah, he says this. And so it would take forever, and it was expensive, and it wasn't great.
Okay,
but it's
so
much better now.
yeah. So basically, right, what we're talking about is there's this new thing. Anthropic's written about it. Manus, some of these other big players. How you can have one orchestrator agent that tells a bunch of sub agents what to do. Right. This is a multi-agent architecture. So with Agent 3, we've really beefed up that multi-agent architecture. And you'll notice, like, what are some examples? There's like a sort of agent that's in charge, and then what other agents do we have that are they're helping out?
So it's really the testing and the code review, and then we have kind of like a general task sub agent that can be used for like various other things. So one of the really common patterns of what happens is you take your task, you implement it, you test it. You find out the feature works, you get it code reviewed, and then we use a different model, which is like very good at this task to handle that step. And then it comes back with a list of feedback, and the main agent, which really trying to preserve that core context and not like fill it up with a bunch of random nonsense. Rather than going through and addressing like the 6 bits of feedback we got individually, we just kick it off to a general sub agent that can like knock out those bits of feedback. And then from the user's perspective, they can continue on with that conversation of like, all right, let me build the feature that builds on top of the feature I was talking about previously, rather than let me build. I don't really want to think about the fixes that it made like as it was working. So it means that we can operate on much longer trajectories.
Very cool. So it sounds like you're saying self-testing, all of these sub-agents allow us to build for a longer period of time.
Yeah.
Cool. And I also realized I just jumped into this without introducing these outstanding engineers. So we're going to go down the line here. We'll start with Darsh. Let you guys introduce yourself.
Well, I'm Dash, as Matt said. I work in the workspace infra team now, but originally, I guess you said I'm the product engineer. I was a product engineer till date. I've been working on things like the visual editor or the visual selector for the Replit Agent, themes, and other fun workspace-related things.
MCP support?
MCP, Figma MCP support, yeah. I think we got that out real quick.
Does anyone in here know what MCP is? Are we excited about MCP?
Wrong room, Matt.
Put your hand up if you use an MCP. That's actually more than I expected.
Okay, so we got to build MCP servers. That's what I'm hearing. But do you want to introduce yourself, James?
I'm James. I'm on the AI team. I've been at Replit for a little over 2 years now. So yeah, just building out everything, putting out fires as they come up.
Outstanding.
Yeah. Hi, everyone. I'm Jackie. I'm on the workspace infra team. Also, a bit over 2 years now. I do all like the stuff inside the container and do all the APIs that James asks me to make. So.
Very good. So we talked a little bit about multi-agent architectures, about what makes Agent 3 different to kick it off. But one thing I think is important, I know there are a lot of like builders here, a lot of people building their own startups or came here from a different place. And you probably hear things like move fast, break things, whatever that means, or like, you can just do things. And so I guess what I want to ask our engineers is, how do you operate in a move fast, break things culture when we're serving to millions of users, when we're building things that need to be on all the time? How do you think about that balance?
So we basically just try and ship as often as possible. We put everything behind feature flags. We do a little bit of evaluation, but a lot of the time it's like listening to customers, dog fooding, and then looking at the metrics about like how they use the product. If we roll this feature out, do the number of test runs, does the number of test runs increase? Okay, that's interesting, but it doesn't necessarily mean that the feature's gotten worse. Do the number of test runs that run fail? Like that's just looking at all of these different numbers to kind of understand it. And the truth is we often don't get it right. So one of the big issues we had with Agent 3 is that a lot of that like internal dog fooding before we released it was on these repos that were actually developed by engineers. So they're actually like quite high quality code. And unfortunately, if anyone who's done a lot of vibe coding and then like actually looked at the code, like it sucks. And so we would, a user would log in and then they would give it a new feature and the new feature would get written and then the code review agent would come in and it would go, what the am I looking at? This is terrible. You need to replace all of it. And then the agent would be like, okay, well, I've got this feedback. Let me start replacing this code. And then the user would be like, I asked you to make the button red. Why have you rewritten everything? Like what's going on here? And so we just had to react quickly and like give users the ability to dial that back. And we didn't really realize that like necessarily when we released it, but there's a very short period where it was off the rails.
So yeah, what James is speaking to there is you might have noticed we have like sliders for autonomy in the demo, right? And so agent would try and do a lot of things. And kind of what he's speaking to is we tested this on a lot of developer written code, not necessarily vibe coded code. So Jackie, do you have something to say to that?
Yeah, I think just to add on there, I think a lot of it just comes down to feedback loops. To iterate fast, you need to get feedback fast, and we have a lot of different venues for doing that. Like James mentioned, we have a lot of like top level quantitative metrics that we look at, like first pass rate, or like what percentage of prompts do people submit that end up in something being successfully shown to the user. We track a lot of those for like a wide variety of different prompts, but we also do a lot of in-house dogfooding, like James said. So a lot of our internal teams actually use Replit to build tools, apps, workflows for their own teams to kind of accelerate development within the company as well. And so there's a lot of these like combinations of like, oh, how do you actually like tighten the feedback loop in a way that means that like, yes, iterate fast, break things, but like you should know when the thing breaks. And so we also have like a lot of means for like user feedback and like data pipelines to kind of aggregate those. So a lot of things going on.
Move fast, break things, know when the thing breaks. I feel like that might be the quote. This is kind of leads into something spicy that people have been talking about, which is like evals, right? Like when you build these applications, how do we know what the output looks like? Do we have a standardized way of doing that? Sounds like we're looking at traces and other data, but how do we evaluate the output? What does that look like?
So the standardized sets of evals, like we've run Swebench and stuff, but at this point they're mostly just like completely saturated and not super useful. Also for the types of applications our users are building and the types of tasks, it is kind of like hard to like. They're not particularly accurate. So Swebench, it's like 30% Django. It's like well-written Python code, which is a very different problem to poorly written TypeScript. Or poorly structured TypeScript. So we have access to some internal repos that we do some tasks on that kind of like are a bit more like that. Not quite as bad as some of what our customers have, but ultimately that's kind of the issue, right? Is that you have this distribution that your customers have, and you have this distribution of your evals, and making them line up is actually a very, very, very difficult task. Especially when you dive deep into these traces and try and understand like how your customers communicate with the agent. And like, I'm an engineer. I work with it. I know what works. I know what doesn't. And there's a lot of just like, I've seen trajectories which is just like, fix it. What does that mean? Fix it. What's broken? Fix it.
Make me $1 million, no mistakes.
Don't forget no purple gradients.
No purple gradients, $1 billion, no mistakes. So it sounds like what you're saying is that the evals aren't really representative of the way that people interact with the agent in practice.
Yeah, exactly.
So do we go on like vibes? What's the solution?
Well, I mean, it really is just the kind of like looking at the numbers of whether customers are actually getting a lot of value out of it, and how does the agent change its behavior when you change certain things. Does it result in users staying around longer? Does it result in like there's numbers like churn and those things. But they're very laggy indicators. But the big one that like we really view as kind of a North Star, and we get really, really concerned if it drops, is the deployment rate. So ultimately, like once you've already paid for something, you've already paid for your website to be built. The number one metric about whether that is something that actually provides value to you is, are you going to press the publish? I want to pay to publish this on the internet. So that number there is like the number one North Star that we use.
I mean, it's that's interesting to think about incentives, right? Like, or rather, what that says. If you're willing to deploy something, like I'm proud of this, I'm willing to show this to other people, right? Is that kind of the thinking behind that metric?
Absolutely. And if a user doesn't like what they're looking at, they're definitely not going to hit that button. They're going to start yelling at us on Twitter, which is also another valuable source of feedback when your CEO has 400,000 followers.
Or me when I look at my Twitter DMs.
Yeah, but I don't get as scared when you Slack me.
Outstanding. So we talked a little bit about some of these sub agents. We talked about how these things work. So I showed a demo and it looked really cool. The agent's using a browser. What's going on there? How's that different from like computer use? Like a model using a browser? Is that a model using a browser? How do we handle that?
Yes and no. It's an interesting like hybrid approach. One of the main things that we were prototyping with is like, how do we make agent testing like cost effective, but also like malleable enough to like get things done. One of the things that we noticed is that when constructing like a testing plan, it makes a lot of sense for the agent to try to gather context about what the state of the website is. What does it know about? Because oftentimes the agent will just write code, but it actually has no idea what the visual representation of the website is. And so the traditional computer use one is like, oh, I have a website, and then I have a form on my website. I need to go click on 17 different buttons and fill out a bunch of different fields to get to the final state. And that's a lot of different tool calls and actions, which take a long time to execute. So one of the ideas that we came up with is like, well, what if you just actually let the agent write like snippets of Playwright? And one, in order to test, and two, in order to explore the page. So it goes through different phases of exploring the page and also making assertions on whether things work or not. And so you'll often see the agent, when it first loads into a page, do a lot of queries to figure out whether things that it expects to be there are there. If they are there, how do I make the right series of actions to get to the next step? And so this kind of hybrid approach of like, oh, we'll use Playwright when it's most like available and I know exactly what I'm going to do. And then also falling back.
If you're on the second floor, please refrain from dropping food onto the folks on the lower floor. Thank you.
That would be great.
Please continue.
That one you can't test. But yeah, for things that the agent has much more trouble driving with Playwright, for instance, like the whiteboard app that Matt showed, that usually will require falling back to more of a computer use-based approach, which involves specifying like mouse coordinates or things that require like manipulating the browser window. We've seen like fun anecdotes of like the agent actually spawning 2 Chrome browsers to test like a multiplayer application and seeing how they interact with each other. So kind of giving it freedom to kind of go beyond its like normal optimized Playwright stuff is like a nice means to do that.
Okay.
Or one time it just resized it to a small screen size so that it can test the mobile view of the
Yeah,
application.
So let's break this down here for me because I am by far the worst engineer on the stage here. So what you're saying is there's this thing called Playwright, which is a testing framework for Chromium, for Chrome.
Yeah, it's a way to drive different browsers to do automated testing.
Okay, so what we're doing is we're using a combination of Playwright to fire up virtual Chrome instances, but then when things get really hard, we're falling back to some other solution.
Yeah, so one fun fact about, I guess, a history of Replit is that before Replit was an agent company, we did like a web IDE. And there was a phase where we were really popular amongst kids who wanted to make Python games. And you can't deploy a Python game as a website. So how do you get to show up in Replit.com, like in the web view? So we had a long prototyping phase of like, oh, how do you use something like maybe VNC, which is like a virtual network computer, which allows you to kind of stream the like a computer screen of a cloud computer as a video somewhere else and interact with it. And so we built that out to earlier support Pygame, but it turns out that if you spawn Chromium in a REPL, it actually connects to the X server within the container, and you just get like a Chrome window that just pops up in Replit, which is really neat. And so we kind of took advantage of that to do a lot of the agent testing, like visualization. So you'll notice in the video that when the agent was testing stuff, you could see like the mouse cursor move and whatnot. And so we have like a humanization layer on top of Playwright that makes the actions of the agent like more consumable. And we also implemented a fun thing like takeover, which means that like if there's something that the agent doesn't know how to test, it can defer responsibility back to the user to be like, hey, I don't know how to log into your Google account. Can you do that for me? And so being able to do that interactive handoff is something that I took advantage of our existing infra, which is really fun.
Very cool. So, right, if you know about Replit, again, I talked about you just go to replit.com in the browser. We also have databases built in. We have like object storage. These are ways to store data, ways to store files. The cool thing is that like you don't need to go to a separate platform to add any of these tools. It's just all built in Replit. And the reason that we can do that is because the platform's been around for Winter YC 2018 has been around for 7 years, And what we're noticing is that some of these other solutions, like using VNC, streaming in these outputs, are the benefits of having a platform that can run 50 languages, that have all of these really cool like functionality built in, that are then enabling us to build on top of it. And that's a bit what Jackie's describing. So really cool stuff. And you also mentioned, right, like vibe-coded apps. Let's tie this back to everyone here that's vibe coding. Agents are really bad at understanding what visual outputs look like. Like, I mean, what's the implication there, right? Like, we're the way that we're helping the agent understand what things look like. How are we doing that? How are we solving for that problem?
Well, I'll go both ways. One is crap ton of data CUI attributes for browser testing to actually work when you're selecting things and finding things. But when a user is trying to point things out in the browser, for example, here's the button which I want to change, or I don't know, make all of these cards smaller. You need to somehow describe that to an agent, which is, I'm exaggerating a little bit, but it's like describing a mathematical formula while blindfolded and just plot this, here's the point. But because the agent cannot see, usually you are giving it a reference in the code base that here's the actual element you are referring to, here's the elements around it, here's the parent element, here's the child element, go find it, so that you don't have to go look at the source code across the entire application. Instead, just know exactly what the user is pointing at. And you can do this in fun ways, like writing a Vite plugin to inject source mapped information about which rendered HTML element belongs to which place in the actual React source code, and then passing it via post message to the actual workspace, and then piping it to the agent, which then we prompt around like the user is referring to this element. Here's the context. It does work sometimes.
Yeah.
There's a lot of stuff going on there. Do you want to elaborate on that, Jack?
Yeah, so because we have like a proxy layer that serves like the user's like application and makes it available on the public internet, we can actually inject fun things both into like the application and into the proxy that allows us to relay information back to the agent that you normally otherwise wouldn't be able to. So we, for example, forward like WebView logs and network requests. So if you're using like the web view and you click a button that makes an API request and the API request fails for whatever reason, we also can include that as context into the agent, which is really neat.
Right, and so like what we're talking about here, if you're vibe coding, right? Maybe you go into Claude and you're like, hey, like write me code, or you're using another tool. It doesn't have the context of all the stuff that might break. In this case, we're providing visual context through code and through Playwright. Like we're giving agent the ability to see in some sense, which is news to me because I've been asking ChatGPT if I look good every day. I was just taking its word for it. It's been lying to me this whole time. But anyway, that's where someone's supposed to say, no, you're wrong, Matt.
No, you're wrong, Matt.
It's okay. Anyway, but we're providing this additional context to the agent through failed API calls, through what the application looks like. And that means the agent is able to have this longer feedback loop where it says, oh, the code is broken. I'm just going to keep fixing it. And that's where we get 3+ hour runs, right? Where you can like, I think James, there's a
a lot of what you're describing is that like human in the loop thing. That works with like agent V1 and V2, but V3, it's really, you don't have to do that. You don't have to generate the failed logs yourself. You don't have to see the error message. You just come back and it all kind of works, which is hypothetically the dream.
Yeah, I think a lot of the journey from like V1 to V3 can be thought of as like, what parts of V1 did the person or human have to do that we can further abstract into something that the agent can do? And so one of them is like testing. Like there was a joke that like after Agent V2, people were like, aha, I'm a glorified QA developer. And so there's more things that now we're seeing like different usage patterns of like what people are actually spending time in the workspace doing that still require a human in the loop that we can figure out how to like turn into things that we can provide automated system feedback on.
So we actually had a prototype of like a traditional computer use agent that we tested for like basically doing what the testing does at the moment. And the feedback we got is that A, this thing's really slow, but B, it's really expensive. And why am I paying like $2 for it to just click on buttons? Like I can click on buttons. I don't want to like do this. This is nonsense. And so that was why we spent a lot of time like getting that cost down. And it really comes down to like users only really like agents when they're doing things that they don't want to do or they think are hard. And if they think they're getting charged a lot more for things that they think should be cheap, like testing whether a button works or not, then they're going to get really upset.
So in terms of token management, cost management, these are strategies to reduce that cost to make users happy.
Yeah, a lot of this stuff. Yeah.
Very cool. I love that. And this is, if you're following along, right? Like a year ago, right? We had models that are writing code. And then we have agents that are writing code, things that take actions on your behalf that can execute things. And now we're sort of thinking in this paradigm of like slow or fast feedback loops, like long feedback loops versus short feedback loops. Do you want to go make a coffee or like, go on a walk or go on a run and come back to something that works? That's like agent high autonomy. Do you want to like iterate really quickly? That's agent low autonomy. With that toggle, you can toggle on. And so as we're seeing these like multi-agents evolve, they're able to do more stuff. They're able to run even longer. And that's like what we're building here. We're building these agents that can just like do your, build the whole app out end to end. They build my demos for me. I don't even really do anything anymore. So this is pretty great. Like they're doing my job for me in some sense, I guess. But if we're talking about, we talked about how these things work. Let's talk a little bit about the outputs. So like, how do we avoid purple gradient, obviously vibe coded, like boring stuff? What goes into design in an agent built app?
Whoa. Okay. First off, there's two modes. Like James mentioned, we did aim for the agent to run for a really long time after you give it a plan to do something. And then there is this other cohort of people who are like, well, I do want a human in the loop process of designing my application really carefully. I want it to look pretty. I want to, pick how all the background colors look, how all the buttons look, just because this is the front end portion which I'm building, and then I can go ask it to do the rest. We have something called a design guidelines step, which after you give the agent a prompt, the agent goes back and is like, okay, this is e-commerce website, or maybe a fun website for my friend. So, okay, it needs to be some funky, fonty website with weird images on top and not a very commercial website because it's for my friend, as the user described. So then it'll go build a theme for it in the background. It's like, okay, fun colors, I don't know, pink, yellow, whatever, and come up with a theme, fonts. It can also generate images so that the website, when it comes out, has pretty images on top, unique ones instead of just some standard boilerplate images. And after all that is done, we realized, okay, well, we want to show previews to the user while the user is doing this human in the loop thing, because writing React code takes a while. Building those components, composing those components, it's a few minutes, and people get bored. So what do? The team had this really crazy idea of being like, okay, how about we stream components into a gallery on the agent preview so that the user isn't bored and can see, okay, well, the agent has built this one component. Now it's building the second component. But if anyone has worked with React code, you know that, well, partial component being rendered on the screen, it's a very difficult task. And on top of that, it's also the LLM generated component, which means that you might not have passed the right prop or whatever, right? Jackie ended up writing this crazy AST parser to just so that it knows the agent made a mistake or not. I'll let you talk about all the Vite server virtual module shenanigans which you did.
Yeah, I don't know how much shop we want to talk, but we
High level.
high level. Okay, cool. We made a Vite plugin that basically watches for changes in like a well-known components directory. If there are components there that have the necessary prerequisites to be considered like an example component, we collect all of those into a virtual module and then we spin up a separate Vite server that like shows a new entry point that collects all the components into a single page. And then we can scroll that page as the agent works and have it hot reload as agent makes changes. And that lets us get to a more interactive experience. We kind of like provide some of the more like business reasoning rationale here. Back when we were still using like 3.5, Sonnet 3.5 and 3.7, we did this little trick, which was we knew that the models were pre-trained on and being very good at translating or like generating HTML pages and making them look really good. But the performance actually really sucked if we asked it to generate React code directly. And so we're like, okay, what if we actually made it a simpler problem to ask it to do a design preview by making an HTML page of the actual app first, and then converting the HTML to React as a secondary step. And so that was like one of the things that allowed us to actually really improve the style of our designed apps. I guess a little bit more context there is that we noticed that 3.5 and 3.7 also have this thing of like context anxiety, which is because we try to build a full stack application, unlike some other like site builders, we run into this problem of like, oh, within a single model call of like, let's say 20,000 tokens, you have to fit both front end and back end, which makes it a lot harder for the agent to like be like, oh, I'm actually reaching the end of my 20,000 token context window. Let me make the front end take less space and look worse. And so we ended up in this case where because it was trying to do too much in a single model call, it ended up sucking. And part of the reason why is that we started moving away from that is like a lot of the new models have like new training mixtures, which means that they perform much better on this task of generating a React app right away. And so we can kind of do away with that HTML streaming process now, which is kind of why we started doing the HTML streaming in the first place and moving towards this component streaming model.
Okay, to break it down, we were streaming in HTML. Correct me if I'm wrong. This was like Sonnet 3.5, 3.7. Rest in peace, Sonnet 3.5. You'll always be in my heart. It's over in like 3 weeks. There's no more Sonnet 3.5. Sad day. Anyway, we were streaming in HTML and because Sonnet 3.5, 3.7 we're bad at that. But then we were converting that HTML to React. But the newer models are better trained on generating React code. So now we can just generate the React directly and show little buttons and components as we're building them.
Yeah, that's right.
Cool.
I think one of the lessons here is that as these new models come out, they're not just smarter, but all of the assumptions you previously made in your products, you need to go back and reevaluate them. Hacks that served you really well with 3.7 won't work for 4, and things that worked on 4 might not work on 5, or things that didn't work on 4 might work on 4.5 now.
Okay, so we have to reevaluate our assumptions about agents as we're building these tools. So we're gonna go through, ask some questions here in a bit. We're just talking at you guys, and hopefully you've learned a little bit about AI agents. But first call out is that we're hiring. We got a lot of roles open. It's hard to find good people or good people here. And you might want to know, hey, like, what's it like to work on a product like Replit Agent, where we're shipping for millions of users? We're building very late or into the evening. We're delivering shareholder value, or so they say. So we're gonna go around. What's the craziest story? Keep it relative, not too crazy. What's the craziest story that you can say in front of a camera about building Replit Agent 3? I'll start. So I was doing a live stream the next day, and it was like very late. And I was told, "You're doing this live stream. We're going live. I think it was like 11 a.m. It was like it was like 1 a.m. and things didn't work. And I was like, well, how am I going to test it before the live stream? And the answer is, I'm going to show up the next day and hope that it works, which these guys absolutely delivered on. They crushed it. But I'm sure they have some more interesting facts to share.
I mean, just the night before, like it did work. I want to be clear that it did actually work. There was like 1 or 2 bugs, but we basically solved those. And then they'd been introduced a little bit before, and then it was like 2 a.m. and then I'm like, all right, guys, hands off computers, like just fucking leave it alone. And then Dash was like, oh, please, just like this one little thing. I'm like, no, it's not a showstopper. If something goes wrong, we're in trouble. And I'm having this conversation, and someone over there is like also trying to ship something, and I'm just like, guys, just hands off the computers.
Pencils down.
And then it was 5 a.m. And that was when we stopped. But the language got a little bit more extreme.
They're addicted to shipping. They can't stop. So
it's true.
Yeah, good times.
Yeah, I think another more infra fun one for people is like I think 1 a.m. the same night, we found out that so for context for evaluating the notebook code for the Playwright stuff earlier, we were using the Node.js VM module with a lot of AST rewriting to get like async executions working. But there is a really
there
weird
were some
quirk.
demonic things going on.
Oh yeah, there's some absolutely demonic things. You do not want to look at the code base. But the VM module has this weird quirk where if you write like event loop blocking code, you can stall the outside process too. And so if the agent like made a whoopsie and was like wild true, the entire like container process would just hang, and we'd have no way to rescue it. And we only found that out at 1. So it was like a 2-hour sprint from 1 to 3 to fix that with like some watchdog logic and whatnot. But it was pretty bad. We have like a more robust solution now that like spawns like the stuff in a worker thread, so it doesn't hang the main one. But it was fun.
Yeah, late night building. A lot of really amazing stuff going into building agent. And yeah, I mean, this is one of the most amazing teams I've ever worked for. Some of the smartest people I am somehow grateful to stand up on stage and talk to. So yeah, now we want to open it up to the audience, right? If you guys have questions, I mean, I think we have 10 or 15 minutes. Yeah, we got a lot of people. All right, so we're gonna do it again. I like to do things fun, so I got this like little plushy microphone that I'm gonna hand this to you, Darsh. Please catch this, all right? Like I know. Hello. So the rules are, right, you catch the microphone, and then you speak into it, and then I'll point out the next person you throw to them. How's that sound? Awesome. Okay, who's first?
So thank you for the presentation. I use Replit and it's pretty cool. And my question is, how much of code Agent 3 is writing for the IDE and for the code base that you release?
We have different parts of the code base, but right now we haven't optimized Agent to work on like larger code bases, and so unfortunately, we're in the process of trying to make a harness out of like our existing repositories to make it work better on those types of repositories, which James can talk more about.
I told my manager I'd get it done by tomorrow night, and I'm like 50-50 on that. Yeah,
And yet here you are, when you should be working. What are you doing?
yeah. No. Replit, like the entire environment was like we started working on this kind of code base, which was like this big chunky monster. Like the AI infra stuff is all about 2 years old. So it was kind of Replit doesn't really support Docker right now. Wink, wink, nudge, nudge. It's coming. But we'll basically we couldn't get it running for a while, just because Docker wasn't there. One of our DevX engineers, who's like really great with Nix, has like slowly been moving stuff out, and so we're now at a point where we can get it kind of running. But that's literally been in the last like couple of months, and then we were focused on Agent V3. So the actual dog fooding of the actual like Replit, the agent on the agent, has actually been fairly minimal, and I'm actually kind of ashamed of that. Okay. But so a lot of the dog fooding has been like the company doing it, and like Luca, who is I'm going to point out, sits like on the other desk from me, and yeah, he gives me a lot of feedback directly.
Coming soon.
Okay.
Sorry, what's up?
No, who's next?
All right, we'll go in the back here. You want to just toss it?
Where?
Hands up, green shirt. Yeah, that's you. Yeah.
Which one?
This guy with the
This one.
in the front, right? In the back in the front. What's your name? Jonathan.
Okay, John. Here.
Oh, all right. Hey guys, this is part of the show. A round of applause.
Sorry.
Okay, Jonathan.
Very inspiring talk. Makes me want to write code.
Excellent. That's what we're bringing everybody out for.
You mean prompt an agent, right?
Yeah. So, what context compression algorithm did you use, and how did you eval it?
So we have like a straight up like here is the trajectory. We do some like summarizations, like as in we show shorter versions of each of the tool observations. That is how it works at the moment. If you read the blog post from Devin and the blog post, well, just Anthropic talking about like what skills have been baked into 4.5, that assumption is probably not necessarily accurate anymore. Compression, I think, is one of those things no one's really figured out really, really well. Like, let's be honest, the Claude Code one is dog shit.
We all love our friends at Anthropic, though. They're really great.
I love Anthropic. No.
Please keep giving us tokens.
So I was having a chat with a friend who uses Claude Code, and I was like, "Hey, are you using like the 100 million token model?" And he's like, "I use it exclusively if we're getting like really close to the edge of my context. I'm on a roll, everything's good, and I just need like a little bit more before that compaction step because it's doomed after that." So our compression is better than the Claude Code one was the last time I kind of evaluated it. But we're actively researching how to do that better. And that was actually kind of one of the driving things of like, how do we dog food it? Because, I mean, you should never let your model compact, or your agent compact. You should always be creating your sessions in like smaller groups. It just works better for everything. So the hope is that we will be better at dog fooding these compaction algorithms and like getting a feel for the metrics, because it's also like hard to measure in the stats and like through your data pipeline and all this stuff. The hope is that by dog fooding we'll be able to get better and better compaction and dial that in.
There we go. All right. I don't see anybody on the top that has any questions. Interesting.
Oh, I don't want to throw it.
All right, think about it, because I really want to see that thing get thrown up there. Anyway, we'll go in the back, hand up. This guy, yeah.
Hello.
Hello.
So my question is, when do you guys recommend using the, higher reasoning capability model? And have you guys looked at the yield of that? Is it always beneficial? Is it only beneficial sometimes? And sometimes it's really expensive. So in circumstances when, it's thinking for a long time and you feel like you get punished and, it was really expensive, how do you guys plan to reduce those occurrences?
You're talking about the high autonomy level, not the high-powered
Correct.
model?
Yeah, I think it's 5x the cost.
So that's the high-powered model. So
Yes.
the high-powered model is just swapping out Sonnet for Opus.
Okay.
It's just a straight swap. You can make your own assumptions about like the performance gap between the two. I don't use Opus in kind of my personal development. I don't think it's worth the trade-offs. We have customers who are less price sensitive than I am, who think that Opus is like, absolutely worth it. Always hit that button. Not necessarily my recommendation, but if you want to pay us 5 times more, then go for it.
So to be clear, right, there are autonomy levels which are new in Agent 3, so you can toggle low, medium, high, max. Then we have this thing that's a little older that allows you to turn on like high-powered mode. And what we're doing is just swapping Sonnet for Opus. Opus is obviously more expensive. It's quote unquote better. Is it like 10%? Or like what's the
Relative to Sonnet 4.0, it was like 2 or 3% better on Sweetbench.
Yeah, so right, these are the things where like as Claude's improving Sonnet, they're not necessarily like the Opus model is getting a little bit closer to Sonnet's performance.
I'm just going to say that there's a 4.5 Sonnet and there's only a 4.1 Opus, and you can kind of figure it out from there.
Yeah, so things move fast, but that's our rec.
Yeah, no, the question comes from, I find it very impressive. Sometimes the switch to Opus, solves my problem immediately. Other times it doesn't feel as beneficial. So I just didn't know if the team had some opinion on that. But I appreciate it.
No,
I get it.
We're trying to figure it out
yeah.
too, man.
A high quality, clear prompt that is like is on Sonnet is probably going to get you a lot further than a bad prompt or a trajectory that's kind of gone by the wayside on Opus. Is my advice.
I agree. I think it could be user error, perhaps sometimes. You have to
No,
prompt
I didn't
well.
say that. It's our fault.
Always our fault. All right, thank you very much. Let's see, any other questions? I can't believe these people don't want to ask questions. On the right, somebody said it in the black hoodie. Look at that.
Hey guys, how's it going? I just had a quick question on how much do you use your own agents to build the next gen of agents? Where and to what degree?
So right, James was talking about this a second ago, which is that actually Replit's really hard. Like it's hard to run in development, like the platform. And if you go on Replit.com, right, it's a container. Like when you create a new app, we have a VM. So what we're working on, what the team is working on, is being able to run Docker containers in that VM, which is currently a limiter to being able to build Replit Agent with Agent. Now, how much do we use Agent to like build apps and then validate the output? All the time. That's like my job, pretty much, is to make demos. As we mentioned, like Luca is over there building some amazing stuff, and the AI team is dogfooding this all the time. We're dogfooding. So in some sense, we're always using Replit to evaluate and understand how things work and then improve the model. But we're a couple weeks out from being able to actually have Agent build Agent, if that makes sense.
It's actually easier for us to not use Docker containers anymore than to get Docker containers working on Replit. But that's a separate effort. Yeah.
Separate. Oh yeah, and so a lot of our development, if you're like into Nix OS, or if there are any like Nix enthusiasts here, we're big Nix shop. So yeah, up here. Sorry, what's your name? Andy. Can you pass the ball to Andy, please? Yeah.
Okay, so just frankly, this is a feature request disguised as a question. Okay, I'm giving you a heads up.
Better than a statement.
Listening. Okay, so what are your thoughts around making it as easy to deploy like a native Swift iOS app to the iOS App Store as it is like to publish it to like a domain?
Well, I would say deploying native Swift iOS apps, the biggest hurdle I would say is honestly Apple. Putting an app, like publishing an app through Apple is jumping, I don't know, like 20 hoops to actually just get to somebody actually reviewing the application, and then they reject it for some silly reason, and then you need to do 2 days of more work just so that they can see that one tiny button somewhere.
Yeah.
Honestly, it's more of a deployment process problem rather than getting it running on Replit problem.
It's actually very good to start up idea.
It's true. People take notes.
We're giving away all the alpha here. This is what.
I mean, all the comes down to like difficulty of running like a web application versus like any other native thing. Native thing requires like Darsh said, like for you to publish something on Apple requires you to have like a developer account. The one-click approach would mean that like we take responsibility for users' apps deployed on our account, which is I don't think anyone has managed to convince Apple to do like well. And so the other way is like you can go make your own Apple developer account and go upload that. And yes, you can write Swift apps in Replit, but yeah, you have to the part of connecting that to your own developer account still remains outstanding.
Yeah, and just to speak to that a little bit, we have some amazing partners, amazing friends at Expo. They do really great stuff. We're working on flows with them. We might have some more stuff to announce soon around that. One of the benefits of Replit is that we have databases built in, so you can, from our friends at Neon, one of which might be here tonight.
Databricks.
Hey, talk to Andre. So yeah, a lot of built-in services that might make that easier in the future, but short answer is it's a developer process. Awesome. And we're gonna do, I think, 2 more questions. So we have a question on the balcony. How are you feeling about this one? Yeah.
I don't know.
Okay, we can raise our hand up here. Yeah, let's give it a shot.
Oh my god.
You got it.
The NFL recruiters are watching.
You got it?
Let's go.
Oh my gosh. Okay, hello.
Amazing catch. Please tell us your name.
What's that?
What's your name?
Hi, I'm Haley.
Amazing hands there, Haley. Great catch.
Great talk, guys. Thank you so much. I have more of a basic user interface question. So I've been using Replit kind of more conversationally, giving it one task at a time to do. And I'm finding it gets hiccups along the way. Sometimes it works itself out, sometimes not. So would you recommend more giving it a full list of like start, this is the entire app I want to do, this is how I want it to be laid out, give it the 200 minutes to really build out the whole platform? Or would you have it be more piece by piece? What would the, situations be for each of those?
I think that a hybrid approach a lot of the time works well. I think a lot of the times the issue with doing those longer runs is that you actually do need to come up with like a pretty clear definition about what you actually want. Otherwise, it kind of just goes off into the weeds, and it builds kind of like what you asked for, but not necessarily what you want. But on the other hand, you're right. Like if you are doing those like small incremental steps, it's kind of a bit annoying, and it doesn't always get it right, especially if it can't kind of see the forest for the trees or the trees for the forest. Anyway, I'd recommend using the planning mode to kind of work with it to come up with a plan of like what the entire thing you want to do is, and then breaking that down so that it can help guide you towards like what are the best small steps to get there, and then do that. But that really is optimizing for that experience where if you're not entirely sure what your final destination is, you kind of just know the general direction. That's kind of like the right way to do it. If on the other hand, you have like a big app already and you're like, I've got this feature, I understand how I want it to work, like let me plan out all of those details and then like fire it off and go have a boozy 2-hour lunch. Like that's how you should use that. But it really comes down to like how well do you know what you want to build?
Cool. And this is the first thing I feel qualified to actually answer, so I have to interject my opinion, and then we'll go to another answer. So I think what James is describing there is like, can you be concise and like very descriptive about what you want to build and understand the tools that are available to you? So in Replit, there's a build mode and a plan mode. We did it first. There's another coding agent that just released one today. I won't say who, but they might follow me on Twitter. That's all I'm saying. Anyway, so there's a build mode and a plan mode. You go to plan mode, you can say, hey, this is what I want to build. Can you help me come up with, how I'd build it? Agent has access to our documentation. This is something we actually didn't talk about today, but I work very hard on the documentation. These gentlemen also write our documentation. And so it actually knows all the tools that exist in Replit. So it'll say, oh, like there's a Replit database, and then it has access to creating the database. So you use plan mode. You can chat back and forth to understand what you're going to build, and then you could execute one of those longer duration runs on like the higher or max modes. Now, again, we talked about feedback loops. Maybe you want to be on your computer building in, that flow state. Low autonomy. Hey, maybe we add this feature and you experiment with that. But context is the information that we provide to the agent, whether that's documentation. Oh, hey, I want to use this service. Here are the docs for this service. Can you do, or I don't even know what the service is. Can you do research and help me understand what that service is? Or this is a screenshot that I want to use. We also have like a Figma integration, providing designs, providing code snippets. So there's the planning phase, but then there's actually the information you give to the agent. And so like for, we have a lot of very technical builders here. For people that are interested in learning how to use AI and get better outputs, these are all strategies. You kind of have to think like a systems thinker, kind of like an engineer or like a builder. What are the puzzle pieces that I'm trying to fit together? What do those even look like? What am I even trying to accomplish? How do I understand the terminology and like the English language enough to stitch those things together? That's like kind of what I instruct people on. But all right, we're gonna do one more question, and then we're gonna let everybody just talk to each other and get to know each other, talk to these fine gentlemen up here. Okay, people are telling me we need to give this guy the ball, and like we have to throw it down. So, sir, prepare.
Oh!
It didn't touch the ground, all right? We're
It
gonna
didn't touch
count
the
it.
ground, it counts. So I think I have a good question to end on. So I think a lot of us here are interested in building agents. I think you guys can all agree that building a good agent is pretty hard. Building
Giant pain in the ass.
Yeah, giant pain. Building an easy agent that like you just vibe code and cursor is probably not that difficult. Like that calls a single MCP server. So my question to you is, if you were to build a new agent from scratch, like Agent 4, and you had to do the tool selection process from scratch today. So like the agents framework, orchestration, tool calling, server hosting, evals, the whole thing. Like what tools would you choose? Like what would be your stack to be like, this is the new best in class? From your, obviously it's opinionated, but like what is that stack for you guys today?
I think that we've changed behind the scenes how a lot of the tooling works. Like, and it's not part of like Agent 1 or Agent 2 or Agent 3. Like, it's behind the scenes. Like, we don't tell people about it because, frankly, who gives a shit about how we modify files? I think we've gone through like 4 or 5 generations of those, even with just the Anthropic models, let alone any other providers. One of the big things, like, a lot of these APIs have kind of like come and gone. We're using kind of like a graph-based approach that's kind of similar to like a lane graph thing that we used to use, but we don't really use it anymore for some operational reasons. Durable execution is kind of like if I was going to refactor and like rebuild this from scratch, like getting native durable execution, so temporal, restate, building those in to the like internals of the agent a lot more would be kind of where I would be going. That's also where we are kind of heading.
Does ingest also do durable execution, James?
Ingest does do durable execution.
Also a great company to look at. We partner with Ingest. Oh, what a coincidence. Sorry.
We are adding on those bits, and one of the great bits is that the AI team is very focused on more of like the research and experimentation, like doing all these things, and we're supported by some great other teams that kind of go deep into the weeds of like figuring this stuff out. So we've got some insane forking stuff that was like for starting up agents and doing it in like these isolated containers and like doing all this stuff. But we might have been able to avoid a lot of that if we'd used one of these platforms a bit earlier. So yeah, that's kind of one of the things that I would be focusing on, purely because like the actual names of the tools that you use, like who cares? You can change that. Like you can A/B test that trivially. The worst thing that happens if you try 2 different tool definitions is that some of your users take a cache miss, and it's like, okay, someone gets charged 5 cents extra. It's not the end of the world. So yeah, that's my recommendation: durable execution.
Do you have thoughts, Jackie?
Yeah, I mean, I would just add on the sampling and branching thing. I feel like there, my opinion is that I think there will be a change towards like biasing towards sampling and more probabilistic things, where it's like the LLMs are inherently a little bit random. It's like you're going to get better results by trying things multiple different times and choosing the best outcome, rather than going down one path and trying to maneuver it a little bit to get to the right place you want. And I think, as we build better platform primitives to unlock basically these branching trajectories, we want to build that like deeper into the infrastructure as well. So we've done experimentations with like time traveling databases. We have copy and write file systems that allow you to like save points in time. And so we have a lot of these core primitives that are like in our infrastructure that we need to tie together in ways that allow us to enable to do this like branching exploration.
The comment we were talking about with Opus before, where like we have customers who are willing to pay 5 times more, and like the best we can do is give them a different model, is like kind of not great. So in the same way that you pay OpenAI $200, you get GPT-5 Pro, which is like a fair bit smarter, but has like different trade-offs in terms of usability. Like those are avenues that we want to explore. There's like a lot of opportunity there, we think.
So what I'm hearing is sampling, durable execution, maybe like parallel type stuff. And then I'll say more from like the hobbyist or like somebody who just wants to build this stuff. Obviously, you can build agents in Replit, but under the hood, where it's powered by open source frameworks. And there are all these developer tools that in the last year, it's insane. None of them existed, right? A year ago, to build an agent, you're writing a loop in Python, right? But now you just go npx create master latest or whatever, and you can have something that works. So creating them, deploying them, there are dev tools out there that can do many of these things. So, if you're just getting started, there are a lot of very low lift ways that I think you can get off the ground. And so those are some of the ways also that our team has mentioned in my build stuff. But I think that's all we have time for today. Thanks for coming out. Thank you so much. Honestly, round of applause for you all, for our speakers, for the Replit staff and the event staff that made this all possible. Thank you all so much. Again, there are so many events. Thank you for coming to this one. Feel free to stay. We have a bunch of food. We have drinks, mingle, get to know each other. Thank you.
Thank you.